Hi students, today we're going to be talking about angles in a circle. This should be a review from Algebra 2. And we're going to start off by talking about what it means to be an angle in a circle and how we use a lot of the words that are associated with that. So we tend to think about the possibility of starting at some position, and we start at 0 degrees or 0 radians, and we talk about rotations from this position where we go counterclockwise is a positive rotation, and clockwise is a negative rotation. We know that a circle has 360 degrees, or 2 pi radians. And in precalculus, the goal is to really move us towards using radians as a measure of angle. We're going to talk a little bit more about that in a couple minutes. We talked about the directionality of rotation. Again, going counterclockwise is positive, going clockwise is negative. Now we're going to talk a little bit about how we measure angles. We have two different ways to measure angles in a circle. The first is with using some kind of degrees. By the way, it's the Greek letter theta. We tend to use that as a variable dealing with angles. Another one that we use is phi. Phi looks like this. We also occasionally use alpha or beta to deal with angles in this class. So if you see those, I'll say what Greek letter they are, but that's something that is a good thing for us to get used to, especially if you're planning on doing some more math after this course. So degrees measure a rotation, and then we have another way of measuring angles, which is how far along a circle would we travel. This type of measure we call radian measure, and it's based on the ratio of the arc length divided by the radius of that particular circle. We end up really thinking about how far along a circumference this would be. So you might think about that if we have a whole circle, we know that's 360 degrees, and a whole circle, if we're thinking about how long it would take to go around the outside, in terms of radians, that would end up being 2 pi radians. There are lots of good videos talking about how we get to radians and where radians come from. For our purposes, we're just going to be understanding that a whole circle is 360 degrees and 2 pi radians. That means that we can convert between these two. We can take some number of degrees, and if we want this to turn into radians, we're going to multiply by 2 pi over 360. That gets us radians. If we want to go backwards the other way, and we want to go from radians to degrees to see what those angles are if we're not comfortable with that, we need to divide by that 2 pi to get rid of the radians, and multiply by 360 to get degrees. We often reduce these to be 1 pi over 180 to make the calculations a little bit easier. I like using 2 pi and 360 because we know that a whole circle is 2 pi r for circumference, and we know that a circle is 360 degrees. We don't really have to deal with learning new material for that. The other thing that's really helpful for us to know is that pi radians is 1/2 of a circle. This is confusing in terms of counting things. So if we were counting, we'd go like, okay, well that's 1 pi. If I kept going, that would be 2 pi. Another half circle would be 3 pi. And I could keep going like this. The other piece that I jumped into as we saw that circle is that we can also have angles that are over 360 degrees. In terms of experience, we deal with this the most when actually rotating ourselves. We can talk about, especially if you played any video games like skateboarding games or things like that, it measures the angle with which you spin in the air. And you can often talk about things like a 720 would be going 2 full times around, because that's 2 times 360. We also have different ways to compare angles in a circle. And I mentioned this is really a vocab thing today. That's where this is coming in. So if we have our circle, we have a couple of different things that are really important for us to know. The first are coterminal angles. And coterminal angles are two angles that end at the same place. So all of our angles start at 0. This is going to be the initial side of any angle that we do. And if I had an angle that was, I don't know, let's go here. So that would be about 135 degrees, or 3 pi over 4. And I had a different angle, and that different angle went the other way but ended up at the same place. These would be called coterminal angles. The other angle down there would be 180 plus 45 would be negative, because we're going in that direction, 225 degrees. That would also be negative 5 pi over 4. And both of those would end up at the same terminal side. So we call those coterminal. Another coterminal angle at the same place could be going around a whole time and then coming back to that same place. That would be 135 plus 360, which would be 495 degrees. I could also say that was 2 pi plus 3 pi over 4, which would be 11 pi over 4. So a good way to think about coterminal angles is that we're starting at something, and we're adding or subtracting 360 degrees to get to that same place. Or we're adding or subtracting 2 pi, if we're in radians, to get to that same place. The other thing that we need to get used to, I'm going to make a new page for this, are angles. And reference angles are a really good way for us to think about how different angles in a circle are connected to each other. A reference angle is defined as the angle made. It would be nice if I could spell. Let's go with the angle made, I'm going to say, to the closest x-axis. So here's what I mean. If I have an angle, and again, we start always at 0, and we end up here. We're about at the same place we were. This one I'm going to call 120 degrees, or 2 pi over 3. The reference angle, I got to figure out what's the closest way to get to the x-axis, and that's going from here to here. That's going to be the measure of our reference angle. We can figure that out by thinking about, okay, this whole half circle would be 180. Going from 120 to get to 180 would be another 60 degrees. Or another, if we're going from 2 pi over 3 to pi over 3. That would be my reference angle there. What's really neat about reference angles is that we can have more than one angle that ends up at the same reference angle. So if I went, I don't know, let's go all the way this way. And this one is going to be at 300 degrees, or that's going to end up being at 5 pi over 3. The reference angle here would be how much does it take to get to the closest x-axis. To get from 300 to 360, that would take another 60 degrees. The reference angle for this would also be 60. And to get from 5 pi over 3 to 6 pi over 3, or 2 pi, that would take another pi over 3. The reference angle for that would be the same exact thing. The other thing we have to think about for reference angles is that they're always going to be positive values. So even if it would take a negative rotation to get to the x-axis, we're going to keep that as a positive value. All right, so looking at this problem, we're looking for a coterminal angle, and we're trying to decide on a coterminal angle that is between 0 and 360, although we're starting at negative 504. We said that coterminal angles could be found in degrees if we add or subtract 360 degrees to our original angle. So let's do that. So we've got negative 504, and to that I'm going to add 360 degrees. Okay, that's going to take me, so negative 500 would be negative 240, 240. And by 240 I mean 140. And then if I go negative 4, that would be negative 144. All right, so we're getting closer, but I'm not between 0 and 360 yet. So I'm going to add another 360. And when I do that, so that's going to be at 220, 216. And that is a coterminal angle that is between 0 and 360 for negative 504. Next question we're being asked is about a reference angle. All right, we know that reference angles are how far do we have to go until we get to the x-axis. And what I'd like to do is just label some points. We've got 0, we've got 90 degrees, or pi over 2. We keep these degrees because this angle's in degrees. We've got 180 degrees, another 90 to be 270, and then 360. The reason that I did this is so that we can see where 293 fits. I know 293 is bigger than 270, all right, so I'm going to go past 270, but not as big as 360. So my angle is going to be somewhere in here. The other thing that I know is that for a reference angle, I want to go to the closest x-axis, and that's here. And I've got to figure out what it takes to get from 293 to 360. I know it takes me 67 to get there, so my reference angle would be 67 degrees. For this one, we're asked to do all of these things kind of together. So we're going to try to find a coterminal angle. We're going to try to find a quadrant that this is in and try to find a reference angle. I'm going to begin this in a really similar way to how I began the last one. But now I'm going to number things kind of in negative directions. So we've got 0. I'm in degrees, so that's negative 90. We got negative 180, negative 270, negative 360. And one of the things that I notice is that for negative 390, okay, so that's going around, we pass 360, and that's only a little bit past 360, so I'm going to go to right about there. And that's my negative 390 degrees. I'm going to answer one question, which is the quadrant question first, because that's easier. So that's 1, 2, 3, 4. This is in quadrant 4. All right, next question is a coterminal question. And I could do this without having drawn the picture. So let's think about this. We've got negative 390. We're going to add 360 to that. That gets us negative 30. I'm going to add another 360, and that gets us positive 330 degrees. That is our reference angle between 0 and 360. What that means is that if I went around in a positive direction, that would be 330 degrees. And then finally, we're looking for our reference angle. And the reference angle is how far do we have to go until we get back to the x-axis. Well, if we were looking at negative 360 and we ended up at negative 390, that's going to be another 30 degrees. That's our reference angle. All right, the next thing we're going to do is convert this from radians to degrees. So we've got to go 13 pi over 4. I've got a pi as part of my radian, so I know I've got to get rid of that. 2 pi goes in the bottom. 360 goes on the top. I'm going to reduce as much as I can before I multiply to simplify this problem. I can reduce the pi's. 360 over 2 is going to be 180 over 1. I can divide that by 4, and I get 45. So we end up with 13 times 45. 45 times 10 would be 450, plus another 135 would be 585. Going in the opposite direction, we're going from 495 degrees. And if I want to get rid of degrees, I also don't have a pi here, so I'm going to do 360 degrees in the bottom, 2 pi on top. Again, I'm going to try to reduce this as much as I can. I might reduce this to 1 over 180. Both of these can be divisible by 5. That's going to be 99. And that would be, so it would be 40 minus 4, those would be 36. both of those can be divided by 3. That's going to get me 33 pi over 12. I can divide both of those by 3 again. That gets me 11 pi over 4.